Hey guys, Bobby from the HazMat guys, and I'm here with a two-part operation on HazCatting. We have an upcoming episode coming up, and I'm here with my good friend, Todd Burton, the mad chemist. And we're gonna be going through, taking you through two different strings, one for a liquid, one for a solid, and he's gonna show us all the ins and outs of it, so let's check it out. All right, we are back with Todd Burton here at the chemistry lab. What do we got today?
Well, we got a little chemistry kit here called the HazCat system.
Interesting.
So this is one of the systems that we use to identify unknown materials, primarily when our IR doesn't work. So this is what we used to use all the time before we got a hold of IR, the infrared spectroscopy. So we got the book, we got the kit. The book comes in a couple different sections. You got the section one, it kind of gives you some measurements up in here. Kind of tries to make it a little bit more precise, you know, a spoon size, a half pea size kind of thing. And then you get into just your basic test, the bulk of the book. So acid test with A, you know, then you go to barium test and copper test, and the book is colored so you can see different colors for your reactions in your test tubes.
Interesting.
Yeah. So then for the big tests, they have their own sections. So this is the water solubility section. So it's one of the main tests that we do. Okay, and then there's also the thermal analysis where we actually burn stuff, and there's about 5 different tests in this particular complex of tests, TA1 through TA5. And if you kind of run short on finding out what it is, you can actually get in even deeper and get into what's called organic analysis. And this one has a pretty comprehensive form to go through the book to figure out what you have. And if it's inorganic, there's an inorganic analysis test to be able to find those cations and anions that may be eluding you in the main chart. And here's where you would look for the cations, being all your metals basically. So if you had potassium, when you burn a little bit of your unknown, you would have a lavender color. Or if it was a lithium-based compound, it would have a very red color coming off the flame. And those would be for your cations. Your anions are on the anions chart, and it starts to show you all the different possible anions.
That's crazy.
Yeah, this is the chart from hell. So you don't want to get stuck on this chart.
That is crazy. Guys, before you think, oh my God, I'm in panic mode, there is a flow chart that I'm gonna have a much better shot of this as, and you can see that each test, each part, takes you into a new part. And so what Todd's gonna basically do is he's going to go through this flow chart. Now, I'm not gonna lie, he's not going to take his time. We have to keep this kind of short. So he's going to take this unknown liquid in this test tube right here, and we are going to figure out exactly what it is. It is clear. I'm gonna say, yeah, it's clear. It looks like something you would find on the street.
It's like water.
Looks like water. And we have no idea what it is. So he's going to start with this unknown liquid chart, and he's going to start going through this, and he's going to figure out exactly what it is. So hopefully let's do it.
All right, so we're going to start at the top of the chart here. It says unknown liquid. These are made for the field, so it's saying, is it metallic? Is it a closed suspicious container? No, we got in that test tube. So we're going to come down to what's called an oxidizer test.
Okay.
So oxidizers are extremely reactive. That's why we do this test first. So we just take a little bit of our unknown, and we're going to put it onto our wash glass here. You don't need too much. The book will tell you the actual calibrated amount, but it's about the size of a nickel or so. I'll see if I can put this underneath. It doesn't give you much better perspective, but it's kind of spreading out. This table's on an angle. Then we take our potassium iodide starch paper, which is used for the oxidizer test. You can do this test is done the same way for liquids and or solids. Get one of these strips. They're not directional. There's just a big little sheet of paper with potassium iodide all over the paper. And then the book would ask you to take a little bit of hydrochloric acid and put 1 drop of your hydrochloric acid, 1 to 2 drops, just to get it wet enough. That's usually enough. And then you just rub a dub-dub down in your liquid or your solid, and you're waiting to see if it turns a black-purple color.
Which it is not.
Yeah, which it did not. So this is not an oxidizing liquid
Aha.
for this particular unknown.
So we've ruled that out.
Ruled it out. So the next test is on the chart. So if you look over here, it says that, I can read upside down, Yellow liquid stains the paper. No, we didn't see that. Any other reaction? What does that say there? It says, let me look at it this way. I can't see it. Paper wilts or chars or is consumed. No. So any other reaction is considered negative. Positive, obviously, we come down here and start to work through the oxidizer branch on this side. So we're going to go any other reaction, and we come down to the acid test.
Okay.
So on the acid test, I could look up the book, but I just kind of know the shortcuts.
Okay.
So we're going to take some acid, the same stuff we use to activate our paper with, and we take about 12 drops and put it onto our unknown. And what we're trying to do is we're just trying to see if we can get any kind of observations out of this. Does it steam? Does it bubble? Does it react violently? It kind of separated a little bit from our unknown for a second there, but nothing's really going on.
Okay.
So not much happening. So on the acid test, there's lots of observations. So it could react violently. It could have an ammonia odor.
Nope.
Could have white
substance appearing.
Right. Could effervesce.
Ooh.
Rotten egg.
Nope.
Nope. And what's
Color
that? Changes color.
No.
So we didn't get any of that. So it says any other observation, we come down to the water solubility test.
Okay.
All right, so we're gonna clean this one off. So on the water solubility test, we're just looking to see if...
And what is in that bottle? It's just...
This is just our waste container. So you wanna manage your waste appropriately. If you get too much of a hazard characteristic, you have to just dispose of it as a hazardous waste.
Okay.
So, most of the time, it's 99% water, because you're always using the water to rinse off.
Right.
So it's a large amount of water containing material. So, but you always want to profile your waste. So now when we get to the water solubility test, what we want to do is use about, this is deionized water, even though it's not labeled, use about a ½ inch of water, take our pen, this is what the book's going to tell you to do, and the meniscus is about right there. I'm just twisting the test tube so I can know where my meniscus is. So if I have a floater, it's going to float right at that line. If I have something that dissolves into it, the whole bank of liquid is going to go above the line. Okay?
Okay.
So it's always best to hold your test tube and test tube holders when you start to do some of these tests, because things can get exothermic, they can get hot. You don't want to drop it in your lap because you know where it's going to go from here.
Hot soup.
Yeah, exactly. So we're going to take a little bit of our unknown, which is here, and we're going to put a little bit of our unknown into our water, and we're going to see how it behaves. Not much going on there.
No, I didn't see anything happen.
It looks like it has dissolved. So dissolved meaning that it's totally disappeared. If it was a blue or green liquid and you put it in here and it totally disappeared, it would have dissolved. Solids, it would totally disappear, it would have dissolved. So I don't see any kind of a line in there. There is a cheat that you can do in the system to see if something is dissolving, and you can take some potassium permanganate and we can make up a stock solution of this. This is just a little bit of a field cheat. Take a very small amount of potassium permanganate. This is what they use in water treatment systems. It's an oxidizer. So potassium permanganate only dissolves into water soluble material or substances. So I can put just a little bit in there, take it out and shake it up. Totally purple. I know that I don't have a floater or a sinker in here. It's totally 100% water soluble. I can take, getting off track a little bit, but if I take a little bit of a floater, which is this, and just for demonstration purposes, if I put a little bit of this on top, you'll see that you're going to get a nice clear level of liquid there. That is a true floater right there.
Yes.
And you see that nice round bottom?
Yes.
It definitely doesn't like water. It's hydrophobic. It's pulling away from the water. If we had a functional group like a ketone or an acetone, you'd have a fuzzy line there because those like water. They're more soluble.
Okay.
All right, moving on. So, our unknown liquid is water soluble at this point. Let's see, where's my water solubility test? Oh. So we're down here. So our observations are floats, would take us off to like hydrocarbon land if it sinks. we can start to work our way down chlorinated solvent land. Here's dissolves. Emulsifies can start to push you towards organophosphates. And emulsification almost looks like whole milk. So ours really is dissolves.
Right.
Comes over here, does it foam or does it sud? So when we shook it up, it really didn't foam or sud. If it did, it would start to indicate some kind of a soap or a surfactant.
Got it.
So nothing on there. Down to pH test. All right, so let's do the pH test. We already have a liquid. I'm just gonna take a little bit of pH paper. It's got 4 dots on it. We like to use this paper because it seems to be more accurate than others. So if it goes this red down here, we got acids. If we get the blues over here, we got bases. Just gonna take a little drop of this, my unknown stock reagent, and let it go all the way down. I don't have anything red. I get up towards the greens. It looks like a 7 right there when you match all the dots. You flip it over. I'm still right around 7. So this is not an acid or a base.
Okay.
Okay, so we're neutral. We're right around 6, 7. So we look at our pH. 0.2 takes us to acids. 10 to 14 takes us to test for cyanide-bearing compounds. So 3 to 9. 6, 7's in the middle, right? So now we come down and we do the combustibility test.
Nice.
We want to see if we can light this on fire.
Let's see if it burns.
Yeah, heck yeah. So the combustibility test is, you always want to stay clean as you go. Otherwise you start to have a whole table full of reagents and it's kind of gets a little bit messy. So what we're going to do with this one, we're going to take these reagent papers, and old school way was just you put some matches in it and you leave the match in it. But for the definition of the HazCat system, it wants to know if it's flammable versus combustible. So you put this piece of paper in there, and then here in a second we're going to fill that up with about a 50-cent piece size of our unknown liquid, and we're going to light this on fire. So if it jumps to the match, it indicates a higher vapor pressure, which is going to indicate that it's a more flammable material. If it just burns our paper there, it's kind of like a tiki torch if it's combustible. If it's combustible, I could take this out, this would be on fire, and this would not. Like a tiki torch, you pull the rope out, oil's gonna stop burning.
Stops.
You put it back in, it's gonna keep burning. So let's see what happens. I'm gonna put down about a 50-cent piece size. I'm gonna bring in my match. I'm gonna come from over here, the table's a little bit slanted. Come in nice low and slow. I'll light the paper. It already lit. You can see that it's on fire right here. See that blue color?
Yes.
So we have a polar material, water-soluble material. See that blue flame right there? If we turned out the lights, it would be a pure blue. I don't know if you can see it behind my glove. So we got a blue flame and a polar flammable liquid.
Okay.
So that usually indicates some type of an alcohol material.
Okay.
So let's see if it's pushing us down that road. So as we get down to here, it's definitely, let me do this again real quick because because I didn't pull out this paper for the audience. Because we can light it on fire again, right?
I like it.
All right. So, boom, it's lit. I can take this paper out now, which is giving you that kind of that organic flame there, the orange portion of it. And it's still on fire in here.
Yes.
You can see that blue. If I stick in the wood right here, my wood's gonna catch on fire. So this is considered a flammable material, not a combustible one. And it's pretty much gone now. So.
Consumed, okay.
Consumed. So over here, combustible or flammable or non-flammable, we're gonna go down the flammable route, and it's starting to push us towards aldehydes, which are water soluble, or ketones like acetone, or alcohols. And it keeps pushing us down. We can see we're coming close to our endpoints.
Okay.
So the next test is the aldehyde test. Usually when you get a blue flame like that, totally polar, it's gonna be methanol almost every single time. You know, you go to the bar, I'm sure you guys have never done this. You go to the bar, yeah, I'll take a shot of vodka. Ethanol, right? 2 carbons. They pour it on the bar, they spill it. You got that nice blue flame, but there's a little bit of a licking yellow carbon flame.
Yes.
Yeah. You go to your closet and pull out some isopropyl alcohol, put it on here. It burns with even more of a yellow flame because it's got 3 carbons, and they're all water soluble. you can almost tell by how much yellow is in the flame as to which alcohol you're dealing with. So we're going to look up the aldehyde test. In the book, we go to all the main tests. We're going to find, there's the alcohol test. Aldehyde test is right behind it. So we need these reagents: distilled water, ammonium hydroxide, sodium hydroxide, silver nitrate, and some filter paper. And then it gives you the instructions, and then it gives you the observations down here. Immediate black, silver, brown is positive for aldehyde. Any other result is negative. And there's always this additional information, which is good to read, because it gives you information like the most common aldehyde is formaldehyde, which is a gas found at 37 to 50% aqueous solutions. So formalin may contain up to 15%. So, all right. So I'm going to grab my stuff that I need here. Silver nitrate, which is 2328. Filter paper, 2341. Sodium hydroxide, which is 2308. 2306. 2308. That's sodium hydroxide. Ammonium hydroxide, 2307. Ammonium hydroxide. And then we got our distilled water. So if we follow the directions are going to tell us to add 12 drops of 2300 to a test tube. So we're going to set this stuff to the side when it's dirty, which is dirty here, right here. And it says add 12 drops of 2300 to a test tube. I got my water right here, so I'll just take 12 drops from here. One, well, that didn't work out very well. We can cut that out. All right, we're going to take 12 drops of water to a test tube. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, that's water. There's my test tube we're making. Add 2 drops of 2328, which is silver nitrate, to the test tube and shake. So we only need 2 drops of this one. 2 drops. Make sure you're a clean chemist and only use the pipette once. Put that one back. All right. Add 1 drop of 2308 and shake well. 2308. Oh, I need sodium and ammonium hydroxide. So 2308 and shake well. 1 drop. All right, and shake well. The best way to shake is just kind of hold it between your finger and your thumb and hit it like this. That should be well shaken.
Very good.
Like any martini should be, or like it the other way.
Yes, of course.
Okay, so we got all that. Then it says add 1 drop to 2307, also to the test tube, and shake well. So it's kind of like making a cake. So if you go over on the ingredients, your cake's gonna suck. You kind of want to stay within the parameters of the volumes. Okay. So now it's asking me to put place a 2341 filter paper, which is this, onto the watch glass. So we're going to take one of these pieces of filter paper, put it onto our clean watch glass here. There we go. Add 1 drop of the solution made from here. So we're going to get 1 drop of this. And it says to put it onto the test paper. Get on there. Alright. I think I got the back side of that paper. Let's see. Seems hydrophobic on that side. Alright, well, we'll leave it as is. The watch glass, add 1 drop of the solution made and step forward to the center. Okay. Liquid, add 1 drop of the unknown sample in the center of the filter paper. So this is our unknown sample. We'll add 1 drop to the center. Alright, I'm going to mix it up a little bit here. So nothing going on. So we should see the immediate black, brown, or a brown or silverish deposit on the filter paper, and nothing's happening.
We don't see it.
So that's a negative for aldehydes. Okay. Clean off and move to the next step. So how many tests have we done so far? We've done 1, 2, 3, 4. I think that was our 5th test.
Yeah.
Usually about 6 to 8 tests you're done. About 15, 20 minutes, depending on what you got. All right, so the next test down here sends us to a ketone test. And the ketone test, we have those pieces in here. Are these little plastic squares. So the ketone test is usually these little plastic squares, and I don't see them in this kit. So they must have used them all up. But what you can do is take your pH paper, because any kind of ketone that you put on polyvinyl chloride or plastic will actually mar it. It will actually dissolve. That's what's like basically in PVC glue. That's how you glue sprinkler pipes together. You take the PVC glue and you dissolve it, and you dissolve the other side, stick it together, it welds it. So that's a ketone inside there. So we should have like these little plastic chips, but I don't see them in there. So we're just gonna take a little drop of our unknown, put it onto here, and see if we can get this to kind of dissolve and leave like a white stain. And it's not doing anything.
Nothing.
So it's not a ketone. So that's a cheat for that system. So we've done the aldehyde test, so we're ketone negative. Now we're down to the alcohol test, which is what we thought it was before.
Okay.
So it's pushing us in that direction. Let's go to the alcohol test. So for that particular test, we are going to need a couple of reagents. We need our nitric acid, which is here. We need potassium chromate, 2334, which is here. All right, and some distilled water, which we have over here. Seems like we're on a roll. All right, so let's move on with life here. We're going to add, so we're just going to follow the instructions on this one. Add 12 drops of 2302 to a test tube, nitric acid. 12 drops of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I mean, I got 13 in there.
Close enough.
Yeah. All right. So we got 12 drops of that in there. Now we want to add 2 drops of 2334, which is potassium chromate. Okay. We'll put 2 drops of this in here. The chrome gives it the yellow color. Chrome is toxic. All right, we'll shake that up. Okay, now if we have a liquid unknown, we want to use 6 drops of our unknown sample to the test tube and shake and bake. Ricky Bobby. 1, 2, 3, 4, 5, 6. Alright, I'm going to let that shake. So it says to start a timer. We can start our iPhone or whatnot, but this is supposed to change from this orange color to a blue-gray color in the book, depending on what type of alcohol it is. 0 to 10 seconds of pure alcohol like methanol, ethanol, isopropanol. And it says here within 11 seconds to 2 minutes is a dilute alcohol solution. And then 2 to 10, it goes on and on for those other observations. Emerald green, DMSO, dimethyl sulfoxide. So we're gonna see how long this takes to change, and we'll compare it to white background. May take a little while. But it should start to turn a baby blue kind of color if it's alcohol. So as you can see, within a minute or two, this turned from that orange yellow kind of color to like a steel blue color, which is indicative of an alcohol. So if we look back over at our chart down here, our alcohol test is going to be positive, which says methanol, ethanol, propanol, or cellulose.
Cellulose.
Yeah, cellulose. Can't read upside down. So this one, being that it was a pure blue flame at the beginning, it's going to be methanol. So if it was ethanol, it has a little bit more yellow like we talked about. So done.
All right, guys. So that might have been a little long and convoluted, but we're going to do the next video is going to be Todd doing it at race pace to see how fast it can be done. So I'm going to mischievously figure out a little bit of a solid that he's going to have to test, and we're going to do it as fast as possibly can be done. So take a look at it and see what you like. Be sure to subscribe and like us down below and go to the iTunes and all the other jazz. So thanks, guys.